Hello everybody and welcome to a screencast on doing test-driven development with Clojure in Lighttable. This is going to be an introductory screencast and the target audience are really newcomers both to Clojure and or Lighttable. I think if you're an expert in one or other of those, it's unlikely that you're going to get too much value out of watching this, but maybe you'll pick up something anyway. But for those of you who are new, hopefully this will help you get started. So what I'm going to do is I'm going to work through a classic TDD kata, in this case string calculator, and I'm going to build a project in Leiningen and get it all set up in Lighttable and get some automated unit tests going and then see how far we can get down the steps in a reasonable amount of time and see what kind of solution we can test drive our way forward to. So that's the idea, so let's get started. So with Clojure projects, the most common way to build and maintain your dependencies is using Leiningen, which has a strange name. It's quite common in the Clojure community to pick weird names for your projects for some reason. I think this one is something to do with a story about ants, and therefore the ant, I don't really know, but it's a really great tool, a really nice way of setting up your project, setting up dependencies, handling plugins, doing the building. It's really nice to come away from the XML hell of Maven if you have experience with that. So you just need to go to leiningen.org, follow the installation instructions for installing it, and I've already done that, so I can open up a terminal and create myself a new project. So let's say line new string calculator. So Leiningen has gone ahead and generated a new project, so now we can open up Lighttable. There's the welcome, and we can open up the workspace and then import that project folder that we've just created. If we go to my home, there's string calculator, okay, selected. Right, so this is the basic project structure you get with an out-of-the-box line new. You get a project Clojure file, which, let me zoom in a bit here for you guys so you can see the text a bit better. That should be better. So it gives you some information about the description of the project. Let's just update that quickly. A string calculator, we can improve that later. Calculator. URL, there isn't one, we'll leave that for now. Eclipse is fine. Right now we're just depending on Clojure 1.5.1, but one of the first things I like to do is to bring in the other dependencies that we're going to be using. So if we pop back to Safari, we can then find the unit test framework that we're going to be using, which in this case is expectations. I think you actually have to put Clojure in as well to make sure you get it as the top. By a guy called J Fields. So if we go to the GitHub, we'll see what it says about. Nope, it doesn't give you the instructions. You have to go here, installing. Okay, so we want this version, 1.4.5.2. We'll grab that one. Pop back over to Lighttable. Add that as a dependency. And the other thing I want to install is a plugin for, let's get back, auto running. So auto expect Clojure. Here we go, line auto expect. So this is a Leiningen plugin that enables us to automatically detect changes to both the code or the tests. I'll show you how that looks later. So Leiningen 2.0, user plugins, version 1.0. Let's grab that, to Lighttable. Line auto expect. Version 1.0. Okay, so we can save our project. There's another plugin, lining plugin that I usually like to install that I can just show you guys quickly. I don't think I'm actually going to install it on this one, and it's called Line Ancient. For a tiny little test TDD project like this, it's not worth installing because we know we're getting the latest version of all of these plugins and dependencies. But the cool thing about this Line Ancient is if you have a slightly bigger project, all you need to do is run Line Ancient from the command line in your project directory, and it will automatically check if you're using the latest version of all the different dependencies. We don't have many dependencies, so it's not going to be worth it, but that's definitely a top tip if you have a bigger project. Okay, so now we have the basic project structure. Let's have a look at what it's given us. So we've got a string calculator folder with a core Clojure file that has a function that doesn't do much, and we have the initial test file, core test, which is using Clojure test right now. I guess right now there are three major choices around Clojure testing frameworks for unit testing. There's Clojure test, which is the default that comes with Clojure. There is mid-year, which a lot of people use and like a lot, and then there's expectations. The reason I've chosen expectations is it's the one that I'm most used to. I like it because it's very minimal. You'll see when so let's get started and write our first test. So instead of Clojure test, let's bring in expectations, and instead of defining a test like this, we just use the function expect. And if we go back to our PDF, which describes the kata, what's the very first test that we're going to be building? So we're going to be building this is string calculator. So basically it takes a string that has one or more numbers in it and it just adds them together. The method can take 0, 1 or 2 numbers and will return their sum. An empty string will return 0. Example, start with the simplest case of an empty string. Okay, so we'll start with a test that tests the simplest case. And I always like to put a comment above each test that describes in natural language, in English in my case, what the expected behavior is. So in this case it's that an empty string should return 0, just like they said. So we expect 0 when we call our method. They said add. I think we'll call it sum a string, and we'll pass in an empty string. Okay, so we'll save that test, and what we can do now is hop over to the terminal and enter our string calculator, and we can do line auto expect. So this is that plugin I was telling you about, and it has failed to load the project. Error login project CL. Nth not supported. I've made some mistake on the way I brought the plugins in. Clearly, I should have copied and pasted it rather than trying to do it manually. Let's go back and have a look what I did wrong there. Plugins is in a user plugins. I think it should have 2. Maybe it's a vector, it's not just a vector. Let's see if that helped. It looks like it's doing something now. It's pulling in the dependencies. Error, refreshing environment, unable to resolve symbol, sum a string in this context. That's right, that's what we expected, because we've said that we've got a function sum a string, and that doesn't exist here because here we just have foo. So let's get rid of foo and create a basic sum a string. So what parameters will that have? That's going to have a string that we pass in, and right now to get this first test passing, we just return 0. So you see running test, ran 1 test containing 1 assertion, 0 failures. So now let's go back to the requirements and see what the next requirement is. Okay, example inputs 1. Okay, so a single digit should return itself. So let's add the next test case. A single digit should return itself. I like to use the naming around these test cases. I've borrowed from Uncle Bob. I don't know if you guys are aware of Robert C. Martin, the guy that wrote Clean Code. and he likes to use the form given, should, then, if you know the given, when, then, so you ignore the when. So you talk about the given, which are the preconditions. So in this case, the preconditions are a single digit, and then the should is the then, what should happen in that case. So a single digit should return itself. So expect 1 when we do some string and pass in 1. And let's see, so as soon as we save this, it should automatically run, and we get 1 failure because we were expecting 1 and it was actually 0, which makes a lot of sense. So now what do we need to do? Now we need to figure out how we can convert a string to an integer. So if we bring up Clojure cheat sheet, which I actually have a shortcut to in Alfred because I use it so often, and we can have a look at strings and see if there's a nice looking function that's going to help us. String format. Maybe it's with numbers. Int. I guess one thing we could do is dip down into Java. As you guys may or may not know, the Java interop with Clojure is fantastic, so we could always just do a parsing. But I think there is a what's it called? Read string. Let's check this one out. No, that isn't what I wanted to see. Read string returns nil when string is nil or empty. Reads data in the EDN format. I think that's what we want. Let's just try it out quickly outside of here and just see if that is what we want. Oh yeah, and there's one thing I forgot to do here. What I wanted to do was connect lighttable up to the Leiningen project. So we'll do that now. So we will open up the command pane and we will search for the connect bar. Okay, and now we can add a connection and we will choose Clojure. And it wasn't that one, it was this one. Here's the project COJ file, the Leiningen file, and we'll let that connect. It can take a little while to connect and get all the dependencies sorted. So read string 1, let's just see what happens when we do that, if it does actually return the number. Connected, it's thinking. Yes, it returns 1, so that is the function we want. So let's do read string. If we save that, we should have fixed one and broken the other one. Yes, so we expected 0, but we actually got an end of file while reading. So we fixed the one case, but now the other test is failing. So basically we're going to need to put in a condition to check if the string is empty. So let's do that straight away. So let's say if empty string, what do we want to do in that case? Or we're going to need to have brackets around that one. If it's empty, then we're going to want to return 0. Otherwise, we're going to want to read in the string. Let's try that. Yep. So now both of those test cases are passing. Do we want to do any refactoring? It's a bit simple right now to need any refactoring, so I think we'll skip that step. I don't know if you guys know, but with TDD, the idea is that you do red, green refactor. So you write a test that should be red. It should highlight a piece of functionality that your code doesn't currently support. And then once you've got the tests green, then you say, okay, well, how can I improve the code? But we don't have much code yet, so we'll skip that refactor step. So let's go back to the requirements. What is the next case? Okay, so we have 2 inputs that are comma separated. So let's think about how we can describe that in English. 2 numbers separated by comma should be summed. Yeah, I think that explains it. So we had 1 and 2, so I guess that should be 3 when we add them. Sum a string 1, 2, and that one should fail. But by the way, normally I would be working with 2 monitors, so you can have this auto expect window up on the other monitor, so you're constantly seeing it. You don't have to flip backwards and forwards. So it's a constant feedback whenever you make any changes to your code. So I'd definitely recommend that. Or of course, if you have more resolution to play with, you can have it side by side with your light table window. Okay, so we expected 3, but it was 1. So now we actually need to do something where we are adding the numbers together. So if we do a read string, so what have we got here? 1, 2. So what we're going to need to do is tokenize the string to split out 1 and the 2. So let's have a play with how we can do that, and let's have a look back at the Clojure cheat sheet. Let's close that one. Let's have a look at strings. Is there a way of lowercase, uppercase, split, Clojure string split? This seems plausible. So first you pass in the string, and then you pass in a regular expression pattern that splits it. That one is based on digits. Okay, but we can just split it based on a comma. So let's just try that quickly. So we do Clojure.string split. We pass it a string, so we have 1, 2, and then we'll have the delimiter, which is, and we'll run that, and we get 1 and 2. Perfect. So let's copy this. And we'll put it in here. So instead of having a fixed string, we'll have the string. We'll get rid of string. Okay, but now the problem is going to be that we have 2. This split is going to give us a list of 2 strings, and we're just calling 1 read string. But that's easily fixed because we can just map this function read string across all of the strings that we get spit out of this split function. So let's try this. Let's see if that. 2 failures. Expected 1 was 1, expected 3 was 1, 2. Yes, of course, because we're actually just reading the contents and we're not actually doing any addition. So let's add that. So let's do, when you have many and you want to reduce it down to 1, then the go-to function is reduce. So we'll do reduce plus, get to the end, save. Now it's working. Nice. Is there any refactoring that we want to do here? This line here is starting to become a bit of a mouthful, so it might be worth extracting this form, the orange parenthesis form, out to a little helper function. What are we doing there really? So it's a conversion function. We're converting from strings to numbers. So let's cut that out and let's create a private helper function here called string to numbers, where you pass in a string. I'll paste that. I like to use this arrow, where, as you guys know, Clojure is a dynamically typed language, which means you don't have to have lots of type information all over your code, but sometimes it means that you need to be a bit cleverer with your method naming or your function naming so that it's clear what you put in and what you get out. So when I'm doing conversions, I like to use this format. String to numbers, pass in a string. Let's save that and see if our test is still passing. They are all still passing. So I'm happy with that refactoring for now. So let's go back to our test and add another failing test. Get back to the red part of our cycle. So let's look at the requirements again. Remember to solve things as simply as possible. Refactor after each passing test. Yep. Allow the add method to handle an unknown number of arguments or numbers. Okay, so that's our next case. Any amount of comma separated, I guess, numbers should be summed. Did they give an example? No, I guess we can choose our own. Sum a string. What should we do? How about 1, 2, 3, 4, 5? What would that be? 15. If I can type correctly. Okay, so let's save that. Now we have 4 tests. So that one worked out of the box. We didn't need to change anything. We were already coping with the multiple with our reduce plus, and our mapping from string to numbers. Perfect. That's always nice. But let's try and create a red test then. So what's the next case? Allow the add method to handle new lines between numbers instead of commas. Example 1, new line 2, 3 should return 6. Okay, so new line character should be treated as a separator, or a comma, I guess, as a comma, should be treated as a comma. So what was the example? Expect 6. We sum a string, and we pass in 1, new line 2, 3. And that one should give us a red test because we don't yet support new line. Okay, so let's get back to the code and think, how can we update this to support that case? So the obvious way, I guess, would be to change the regular expression so that it copes with commas and new lines. Would that fix it? Yep, as simple as that. So I've got the test green, and now I can think about refactoring. One thing I'm a bit worried about, I shouldn't skip ahead and read the rest, but one thing I think that's happening here is that they're going to be adding new types of delimiters, and I'm worried that this is just going to grow and grow as we add more special cases for different types of delimiters. So I'm wondering if there's another way to do this that gets to the heart of the problem a bit better than just doing a split. So if we look at our tests again, what we're really saying is that we just want to grab all the numbers that are in the string and basically ignore any of the other formatting that's going on. We just want to grab every number and sum them up, and then it doesn't matter what you put in the middle. So if we go back to the Clojure cheat sheet, is there a string function that will let us do that? So regexp, yeah, it's going to be a regexp, isn't it? Reseq returns a lazy sequence of successive matches using a regex matcher. That actually looks quite nice. Oh, and in this one you actually give the pattern, the regex pattern first for some reason, and then the string after, which is backwards to what it was from the split for some reason. I'm not sure why that's like that, but anyway, this reseq function sounds like it could do what we want, so let's give that a try. So let's just change this. That's the great thing about doing TDD and having these tests behind us, that we can just go in now and refactor, and if our test is still green, then we can be pretty confident that we haven't broken anything. So let's swap the order around. So now instead of splitting, what we're saying is, instead of saying what do we want to split based on, we want to say what are we actually interested in, and what we're actually interested in are digits. So let's just grab all the digits and let's see what happens there. Okay, so tests running, 5, green, perfect. There's one thing that I'm not super keen on when it comes to Clojure, and that is some of the built-in function naming. This, for example, is not my favorite name of all time, reseq. I think the trouble with it is that if you don't read the documentation about what it is, it's pretty much impossible to guess it the first time you see it. There's nothing that tells you it's about regular expressions. And to me, that's the definition of bad naming. A good name should be something that clues people in on what something does. I understand that that Rich Hickey and the Clojure core guys like to have succinct code and have short names for things that you use a lot. And I understand that it's a weighing up, but I would have really loved for this to be called regexp or something that just gives you a bit more of a hint. It looks like if we go back to the cheat sheet, it looks like all of those regexp ones are all called re, and to me re means to do something again, but anyway, that's enough moaning about that. Rich Hickey is a much smarter guy than I am, so maybe there's a good reason for why it's like that I don't understand. Okay, so let's get back to a failing test now. We've done the refactoring, so what's the next piece of functionality that they want us to add? Only correct input should be tested. Allow the add method to handle a different delimiter. To change the delimiter, the beginning of the string will contain a separate line that looks like this, // delimiter. Okay, so here's an example. Let's copy this example. Yep. No, not with a keyboard. I can't. It's a PDF. Back to light table. So custom delimiters. Delimiters should be treated as commas, as separators. I'm going to go back to that, separators as a separator, because the comma isn't really the interesting thing, it's that it's separator. Okay, and what was this example? It was some summer string. What's going on here with the, it's a different type of quote. What do we expect in that case? 1 and 2, so that's going to be 3. So let's save that. And that actually worked straight off the bat, and that was because of the previous refactor idea, because now we're just blocking out the digits. We're blocking out the numbers rather than doing any kind of fancy handling around the delimiters. Maybe it kind of goes against them. Exactly what they're trying to get to. Maybe this is some kind of cheating, but it seems to be working so far, so let's see if it breaks later on. So let's go back to the requirements and see what the next thing that they want us to add is. Calling add with negative numbers will throw an exception. Negatives not allowed. Okay. Exception handling in special cases. I might just, I'll come back to this one. I want to skip over that one for now and see if we can come back to that one. And let's hop over to this one. Numbers bigger than 1,000 should be ignored. Example, 1001 2 returns 2. Okay, so let's add that case. Numbers bigger than 1,000 should be ignored. So we expect 2 when we're given summer string, what was it, 1001 and 2. Is that right? 1001 2 returns 2. Okay, so if we save, let's see how that goes. One failure, expected 2 was 4. Was 4. I was expecting that to be 1003, not 4. 1. Okay, I think I see what's happening. I think there's a problem in my regular expression where I'm just extracting each individual digit. So I'm adding 1 plus 0 plus 0 plus 1, which is 2, and then I'm adding 2, which is 4. So I need to fix my regular expression so that it actually takes, I guess it's several digits in a row. So I think we can just say plus. Would that work? Yes, that works. So now it is actually 1003. So expected 2 and it's 1003. Great, and now we actually need to put in the special case that copes with this. So this is returning, this string to numbers is returning a list of all the numbers, and what we can actually do, the easiest way is probably just going to be to filter that list and say, let's do an anonymous function that says if it's less than 1000, only let the ones that are less than 1000 through, basically filter out the ones that are greater than 1000. So if we save that, how does that look? Great. So now we're back to green again. Refactoring. Is there anything else we can do? Maybe this is okay to have a reduce and then a filter and then the function. There might be a neater way of doing that. Oh, one thing I've just thought of though, because now we are extracting the numbers, it could be that in this original case where there aren't any numbers to extract, we're just going to have an empty list here, and when we do reduce plus on an empty list, it should return 0. So it could be that we've gotten rid of the need for this special case. Let's check and see if that is true. Yes, that's great. So we've simplified that even further. So now it's literally just 2 lines of code to support these cases so far. Okay, but now let's go back and add, what was that one about exceptions? So calling add with a negative number will throw an exception, negatives not allowed, listing all negative numbers. Okay, so let's add the case for that. So how do we describe that? negative numbers should throw an exception, something like that. So I think we can even do that with expectations, but I'm not sure, but we'll check and see if that works. So sum a string, and what were there any example ones? -1, 2, it said -1, comma 2. So let's save that. Yeah, I think that was the right formatting. So look, it says did not throw an exception. So we've got one failure. Okay, so how are we going to get this to throw an exception? So we need to check if this is returning negative numbers. Okay, so let's start by defining a local var that we can call numbers. I'll grab this. Let's cut that out and paste it in here. And then what we can do is get rid of that extra bracket. We need to add an extra one at the end, and let's just do the formatting. If we save that, hopefully we're back to where we were with just one failing test. Yes, that's right. So now we need to check. Now we have access to these numbers, so we can check whether or not they have any negatives in them. So let's figure out how we're going to do that. We're probably going to want to use a when let. And let's say negative numbers. So we're going to do something with these numbers and figure out if they're negative. So let's filter the numbers using the neg function and pass in numbers. Okay, so when we have negative numbers, then what we're going to do is throw a new exception. So throw no, we didn't know about that one, exception, and then we're going to pass in what was the message that they wanted. Negatives not allowed, colon. Negatives not allowed, and then we want the list of negative numbers. Great. And then, okay, so let's talk about what this is actually doing then. Now I've managed to get something out. So the when let says when this var actually gets populated with something, so when we've filtered, when the filter has actually returned some negative numbers, then we're going to throw an exception and list what those numbers are. But when this filter doesn't return any, i.e. we don't have any negative numbers within numbers, then it's going to hop over that and we'll just do the reduce like before. So let's save that and see if that works. 7 errors. Negatives not allowed, lazy seq. Okay, so I've clearly done something stupid here. What have I done wrong here? Exception in actual. Negatives not allowed. So everything is getting, all of the tests say there are negative numbers even though there aren't. Okay, yeah, I think I know what it is. It's when you, let's check this. I think this is what's happening. Filter neg. So if we have 0, 1, -1, and run that, okay, we get -1. What happens if we get an empty list? So the when let is checking if it's nil, but it's an empty list. So then what we're going to need to do is say not empty negative numbers. I think that's what we were missing. Let's get rid of that little test code and save. How does that look? Okay, did not throw exception. Okay, so we're back to just one failing test. It still didn't throw an exception, even though there was a negative number. Not empty, negative numbers. Did not throw an exception. Oh, I think it's because my my regular expression here is actually filtering out the negative numbers before it even gets to this filter, because I'm not taking it. So let's see if I can say that one, or a negative digit with any number of length. Would that help? Yes, we're back to green test. So that was the problem. I was doing 2 filters for negative numbers when I only really wanted to do 1. Okay. So let's go back to here. Where have we gone to? Delimiters can be of any length using this syntax. Oh, and let's think about, we got it green, but let's think about refactoring. Is there anything I can do to improve this code? It reads pretty well. This error handling case has of course added some extra complexity, but I think it's still okay. I'm happy with that. So let's try the next case. Delimiters can be of any length. Okay, so let's think about how do we describe that as a new test case. Multiple character delimiters should be treated as separators, just like all the other ones. Okay, so we expect something, summer string. Did they give us an example? Okay, this bad boy should return 6. Oh, and it's the wrong type of double quotes. And let's change that to expect 6. Now that should just work if my, yes, 9 tests passing. And again, this is just because I'm just, my regexp is just blocking out these numbers here. Get off, paste, what are you doing? Okay, next one. This is easy. Allow multiple delimiters using this syntax. Okay, let's not grab that horrible double quote. Let's grab those. So what is this case? Multiple delimiters, I guess, instead of multiple character delimiters. Multiple delimiters should be treated as separators. Expect whatever it was, summer string 1, 2, and 3, so it should be 6 again. And again, I think this should just work. Let's save it and check. Yep, 10 passing tests. Handle multiple delimiters of any length. I mean, that's going to work, isn't it? Because of how we've done it, but let's just write the test just so we've got it there. Multiple, I cannot type, multiple character, maybe I should, character delimiters should be treated as separators. Change that one to be the same. I don't think they had an example, so we can just make one up. Summer string. So we want multiple and multiple. Let's grab that one, paste it in there. And we also want percent. Let's change that one to a percent. Oops, that's not going to work because expect minus. It's actually green. That's weird. If I change that to 5, so I'm expecting it should be 6. I don't know what that was. Maybe it was just somehow that formatting was legal and somehow gave the correct answer, but that was unexpected. Okay, yeah, that looks right. Let me just double check if I change it to something else. That fails, but minus works. I have no idea why that is the case, but it's some Clojure language quirk that just happens to make that be true. Okay, so let's look. We have green tests. If we go back to the requirements. We've covered all the requirements, and yeah, let's have a look at how our code looks. So I think it was switching from doing the Clojure string split to picking out the numbers from the string that allowed us to keep the amount of code down. Whether or not that's considered cheating by some, I'm not sure. But I like how this has ended up actually. One thing to note, that's basically the end of the TDD part of it, but one thing to note for people that are using Lighttable, if you like the look of the theme I'm using, that's actually a custom theme that I made. If you want to get that and try that for yourself, you just need to go to the Lighttable discussion Google group and do a search for rainbow, and it should be somewhere high up. Here we go, Journo. This is the name of the theme, and then you can just scroll down to the bottom and find the latest one that has an attachment, because I've been making a few updates, and then you can just grab that, and there's instructions for how you install it. Where are those? Here they are. So if you want to try my theme out, copy the CSS file to core CSS themes and just change the set theme setting to journal. In the latest version of Lighttable, let's have a look at that. So we look at user behaviors. In the latest version of Lighttable, a lot of the settings you actually can edit here in user behaviors, and you also have user key map. I've actually made a couple of custom changes here. I like to be able to zoom in and out and then reset the view. You saw that when I changed the size of the text. So I've done that with pmeta, which is on the Windows, on a Mac it's the command key. I guess on a Windows machine it would be the Windows key, I'm not sure. And also have a shortcut for showing and hiding the workspace, Command Shift W, so that's also quite useful. So that's how you customize your key map, and this is how you customize the behaviors. It gives you an autocomplete when you start entering new changes, so you can just search for what you want to change. So let's try that. So if we just wanted to change the font settings or hide line numbers, there we go, we've just changed, and we just save and it will automatically run and update. The new version of Lighttable is really shaping up and being very nice. I think that's about it for what I was going to show you guys. I hope somebody found at least some of this useful, learned something maybe about Lighttable. Probably not the best introduction to the coding, because maybe I didn't really explain the thinking behind Clojure and functional programming well enough for somebody who's totally new to that to be able to keep up, but hopefully it whetted your appetite a little and got you interested in trying at least one of these things out. So thanks for watching, and see you in the future hopefully. Cheers.